Hello, my name is Amjad and my group member Soroush will do intermediate fluid project. We'll design a convergent-divergent rocket nozzle, and we have to use ANSYS 19.1 to design the nozzle. We'll start with the fluent and we'll draw lines to design as a given in research paper uh, polylines, and for in x and y axis. After that we will put the dimensions. We have to make first of all we have to make the lines symmetry, and we will make input for dimensions as given. And after getting done from putting the dimensions for each line, have to go to concept and select surface from the sketch and apply that for our geometry in XY plane. Now we'll draw a line in the middle of the nozzle, where there is an edge between. And now going to tools and select face split for the line to make the two sections. After that we'll draw parallel lines to make this region more critical, and to find to make it to have better results in terms of having meshing, using meshing divisions. We'll make each line away like 5 millimeter, and for each line we need to use a face split, so we make it more divide. And as you can see here, each green region have a different section. I'm getting done from splitting the regions to become 4. After that we have to save our geometry and update it to go to the next step, which is mesh, applying mesh. Making update for each step is very important. Now we have to insert the sizing for the lines that we draw before, and apply it. And we will choose a number of divisions. I will make it 10 divisions, and also make for walls lines, and make the same thing, number of divisions 10 as a start for mesh 1, to see how the result will behave after making different meshing. Now we have to generate, and as you can see the mesh is unstructured. And now my colleague Soroush will continue speaking about it.
Okay, we use mapped face meshing to make the mesh uniform. As you can see, generate the uniform mesh, and the mesh will be uniform. So we go to method, select the geometry, then apply. So we have automatic method. We select the all quad, select the geometry and apply. And we have to generate the mesh again, make sure everything is updated. We update, everything, edge sizing, face meshing, and automatic method. And now we have to select the name selection for all the boundaries. Inlet first on the left side, on the right edge, and the exit is the outlet, and we select all the walls and we name them walls for the name selection. Walls. Then press OK. Then everything we check: inlet, outlet, walls, everything is fine. Then now we can save and exit from the mesh, so we can go to the solution after that. The mesh is uniform for this number of divisions. This mesh is 10 divisions, and we have to do it more different number of divisions to also account for the mesh independent later. So this is, we go to the setup. Okay, in the setup, since it's a compressible flow, we have to make density based here. After density based, we go to the models, make the energy equation on, and then we go to the material, air. We have to make the density ideal gas, and viscosity is Sutherland as given in the paper. This is the setup. Then we close it, check again, everything is set, close. Then we go to the boundary condition. This is very important. And the inlet as given, the type should be pressure inlet. Type pressure inlet. Then we go to the gauge, total pressure. Total pressure is given 300,000 Pascal. Then outlet is nothing, we don't change outlet. The walls, stationary walls, no slip, check, fine. Everything is set. We go to reference value. We have to make it compute from inlet, and reference zone solid surface body. We have to change it. Then we go to monitors. We have to change the residual to make our solution more accurate. 0.401. This is not given in the research paper, but it's a standard. We use this residual. Then report plot. We have to make it like drag coefficient CD1 new force report drag. Then change it to CD1. Select the walls. Press OK. This is the drag coefficient. OK. Select the CD. OK. Select those. And after the report plot, we go to initialize. Standard initialization. Compute from inlet. Then we don't change anything. We initialize. After the initialization is done, we have to run the calculation. We use 500 number of iterations, and we calculate. The solution converged, as you have seen, and we go to contour to see some results. Field, we want to see the pressure, static pressure. The minimum value is given in the, this is the contour plot, this is the minimum value, maximum value in the menu, and it is validated by the paper. They match each other, so we can select the velocity Mach number for this number of divisions of the mesh. Different number of divisions mesh, different results. So this is only for 10 number of divisions, as I said before. So for the next steps, we have to change the number of meshes in order to see that are we getting the same results or not. We have to continue different number of divisions in order to solution will be converged and stay the same. Minimum, maximum for temperature, as you can see in the video, and we can even plot the XY plot to see the pressure, static pressure near the walls. We select the walls to see the static pressure near the walls, and also we can see the velocity Mach number near the walls. This is the plot. Okay, now we got all the results. Thank you for listening, and this was our intermediate project.